Hello viewers, this is Medical Science Lecture Room. Today I'll be discussing with you on a polynomial expression or question that leads to simultaneous equation. It is an examination question, but this question tends to bring together simultaneous equation and polynomial equation. However, the presentation is pure polynomial, but as you try or attempt to solve it, you find yourself solving a simultaneous equation. Just to inform you, in this channel, I give medical tips or medical education to my esteemed viewers at the comfort of their living room. Again, I run classes for students of physics, chemistry, and mathematics. In case you are new to this channel, please hit the subscription button, turn on your notification bell so that once new videos are made, you'll be first to be notified. Again, like this video and share if you find value. Have before us a question that goes this way. The question says, if x squared plus 2x minus 3 is a factor of a polynomial which is f of x equal to 2x cubed plus ax squared plus ax minus b, where a and b are constants, find the values of the constants a and b, and hence 1. Factorize f of x completely. B. State the zeros of f of x. C. Find the remainder when f of x is divided by x minus 5. I told you earlier that the presentation is polynomial, but here, as you try to solve or respond to this question, you will end in simultaneous equation, and then you go back by applying polynomial principles to get the final answer. Now, we'll begin from the first statement. The first statement said x squared plus 2x minus 3 equal to 0. We're told that is a factor of this. What that statement means is that when you use this to divide this, the remainder will be 0. Therefore, it means that if you also factorize, because you know that x squared plus 2x minus 3 is a quadratic equation, it's also a polynomial with degree 2. It's a polynomial expression or function with degree 2. And of course, you call that quadratic equation. If you factorize it, or if you solve this, if you find the root of this equation, if you find the factors of this equation, those factors will also be factors of this equation. If you find the root of this equation, those roots will also be the root of this equation, because the original equation divides this equation without any remainder. So we have to factorize this equation first. Now, in doing that, I have done a video about how to factorize a quadratic equation and give a number of ways you can factorize a quadratic equation, or you can solve a quadratic equation. We say we have the formula method, the remainder theorem method, we have the factorization method, and so on. Now, but here I will apply the method of factorization. Now, if you are to factorize this, why is it important that we factorize this? I need to know the root of this equation, because if I get the root of this equation, those roots will equally be the root of this equation. I will now use those roots to substitute and apply the remainder theorem principle to this to enable me to have the value of a and b. Remember that the value of a and b are constants, and they asked us to find those two values. Now, if I'm to factorize this, the first thing I have to do is to ask myself, what is the value that the number that stands in front of this x squared? You will agree with me that it is 1. I will say 1 times minus 3. When minus 3 here is constant, of course the answer will be what? Minus 3. I will now look for two numbers such that when I add the two numbers together, I will have 2. If I multiply the two numbers, I should have minus 3. That's the rule. The rule is that you first use the coefficient of what? X squared to multiply the constant, and then whatever you have, you write it by somewhere, and then look for two numbers such that when you multiply the two numbers, you will have this minus 3, and when you have the two numbers, you have the number that stands in front of what? This x. Now, if I take numbers like 1 and 3, you see that 1 and 3, 1 times 3 will not give you minus 3. 1 plus 3 is 4. It will be what? 2. Because of that, I will say, what if I say minus 1 and plus 3? If I say minus 1 plus 3, it becomes minus 1 times 3. It will give me minus 3. It becomes minus 1 plus 3. It will give me what? Plus 2. And so the two numbers are minus 1 and plus 3. Now, what I need to do next is to now bring the x squared down. Then I will now say plus. These two numbers, I will place them inside a bracket and then place the x outside. Why am I doing that? I'm doing that because minus 1 plus 3 will be what? 2. So I'm simply substituting the 2 here with those two numbers. I will now go ahead to say minus 3. I bring down minus 3 and that is equals to 0. I try to remove this sign of proportionality. I try to remove this bracket. If you remove the bracket, you're going to have what? X squared minus 1 will times the x here become minus x, plus 3 will times the x here become plus 3x, and now minus 3. And of course, this is equal to 0. I will take these two together and I will take these two together. And now, what is common here is x. What is common here is x. I will now say x. I'll put that x outside because x is common here and x is here and x is here. I will place the x outside and I'll place another x here such that this x times this x will give me x squared. And I have minus 1. Minus 1. Placing minus 1 here means that minus 1 times x will give me what? Minus x. So what I have here, if I multiply this, I will get back this. That is all for this bracket. I will go for the next bracket. What is here? Common here is 3. There is 3 here, there is 3 here. So I have to place 3 outside and then x minus 1 such that 3 times x will be what? 3x. 3 times minus 1 will be what? Minus 3. Now, having done so, I see that what is inside this bracket, the content of this bracket is x minus 1. I will ask myself, is this other bracket x minus 1 also? Of course, you see it's x minus 1. Because this is x minus 1 and this is x minus 1, it shows that I am absolutely correct. Now, at this point, I will now say this x together with this 3 and then the x minus this. Since this is equal to this, I will just take one of them. Now these are now factors. This is factors of this and they are also factors of this other expression. Factors of this and they are also factors of this expression. Now what next am I supposed to do? I will look for the root. For me to get the root, I will remember that this equation is equal to 0. Therefore, x plus 3, which of course is a factor, should be equal to 0, and then x equal to minus 3. Therefore, we have one of the roots here to be what? X equal to minus 3. I will now go for the second root, x minus 1 equal to 0, and this is equal to 1. That means we've gotten two roots, x minus 3, x equal to 1. The roots are 2. This one and this one, because the power here is 2. But remember that this equation here has power 3. Therefore, the root here must be 3. Two of those roots are this and this, and the remaining root we do not know, which is why the examiner say factorize completely. By factorizing completely to help you get the third or the remaining word root. Now, see what I'm going to do now. Since we've gotten x equal to minus 3 and x equal to 1 as my root, I will now say if x is equal to minus 3, I'm taking the first root, x equal to minus 3. I will look for the remainder. I will now say the remainder is equal to f of x, and that of course is the same thing as f of minus 3. What this means is anywhere, remember what is our f of x? Our f of x is this expression. What this means is that anywhere we have x, we will replace there or substitute minus 3. So I will now have this to be equal to, in this expression, that will become 2 into minus 3 raised to power 3. Of course, this x is raised to power 3, plus a into minus 3 raised to power 2, plus a into minus 3, and then minus b. This will, of course, minus 3 times minus 3 times minus 3, that will be minus 27, and minus 27 times 2 will give us minus 54. Remember, we are saying that remainder is equal to. Remember, we are saying remainder is equal. It is the remainder we are looking for. Now, minus 54, this square will give us what? 9. 9 times this will give us plus 9 what? A. And this is minus 3a. And this is minus b. Now we again say r is equal to, remember, what is our r in this case? The r is the remainder. The remainder is 0. We were told that x equal to minus 3, of course we got it from x plus 3. We say x plus 3 is a factor of this, and they told us that this is also a factor of this. That means for this to be a factor of this, it therefore means that x minus 3, if you substitute, if x minus 3 divides this, the remainder will be 0. For that reason, our remainder is 0, because the original expression this is a factor of this. Now that will give us 0 for r, and that will be equal to minus 54. 9a minus this will give us plus 3a, sorry, plus 6a, that will be plus 6a, and then minus b. And now with this, we try to the minus 54 crosses to the other side of the equation. That will become 6a minus b equal to 54. We call that equation 1. So we've gotten the first simultaneous equation, which is 6a minus b equal to 54. Now, that is when we use x equal to what? Minus 3. Let's say, what if x is equal to 1? Let's see what we're going to have if x is equal to 1. If x is equal to 1, we look for the remainder. Remember again, f of 1 is equal to what we did here. Similar, we're going to do the same thing. What we need to do is to substitute the value of what? X for 1. Now in this expression, that will now becomes r equal to 2 into 1 raised to power 3 plus a into 1 raised to power 2 plus a into 1 then minus b. And then remainder is 0 equal to this, of course, 1 raised to power 3 is 1. 1 times 2 will give us 2 here. And then this is 1 times 1, that is a. 1 times a, that will be a. And here will be 1 plus a and minus b. We're going to have 0 equal to 2 plus 2a minus b. Because a plus a will be what? 2a. Then we will try to let the 2 be moved to the other side of the equation. This will become what? 2a minus b equal to minus 2. And that will give us equation 2. So we've gotten two equations here. We have equation 1, which is 6a minus b equal to 54. And then we have equation 2, which is 2a minus b equal to minus 2. So we will now solve this equation simultaneously. We say solve equation. We solve equation 1 and equation 2 simultaneously. If you want to solve equation 1 and equation 2 simultaneously, let me bring them down. Equation 1 is 6a minus b equal to 54. Equation 2 is 2a minus b equal to minus 2. Remember that a quadratic equation can be solved either by the method of elimination or the method of what? Substitution. I would like to use elimination method here because I know that the coefficient of this b is 1, the coefficient of this b is 1. So the b can be eliminated straight directly without necessarily having to do some manipulation. So I will prefer to go forward the method of what? Elimination. Now if I'm eliminating, the variable I'm to eliminate first will be the letter b, variable b, the constant b. So I will draw my line here. I will introduce a minus sign so that I can say 6a minus 2a. Of course, 6a minus 2a will give us what? Forward a. Now here becomes minus b minus b. That will be 0. And then we now say 54 minus 2. That of course will give us 56. A will be equal to 56 divided by what? 4. Of course, if we divide, 2 here will be 2. 2 here will be what? 28. 28, 2 here will be 1, 2 here will be what? Simply 14. So we're going to have 14 as what? The value of what? A. A is equal to what? 14. So the value of A is 14. The value of A is 14. Now, having gotten the value of A, we can quickly get the value of what? B. Let's find the value of B. For you to get the value of B, you can substitute. You can say substituting a equal to 14 in either of the equation. I may decide to substitute in equation 2, that in 2a minus b equal to minus 2. Now if I substitute, I will have 2a minus the b. Remember that we are looking for, at this time we are looking for b, but a is already known. So I will have 2 into 14, where 14 is what? A. And that will be minus b equal to minus 2. This will give us 28 because 2 times this will be 28 minus b equal to minus 2. Then minus b is equal to minus 2. Remember, we are trying to make what? Be the subject of the formula. So I'll bring minus b down equal to, of course, there is minus 2 at the right hand side. Then 28 transferred to the other side will become what? Minus 28. This will now be minus b equal to minus 30. Minus b equal to minus 30. Of course, b will be equal to plus 30. So finally, we've gotten the value a, it's equal to 14, b is equal to 30. These are the two values of what? The constant. we've answered the first question. This first question says find the value of the constants which are what? A and B. A is 14, B is 30. So at this point we've gotten the value of the constants A and B, and this was the first demand of this question. Now A is 14, B is 30. Now we have to react to the first question here that says factorize f of x completely. Now for us to factorize f of x completely, it therefore means we have to substitute the values of this constant in the original expression. Of course, f of x is given as 2x raised to the power 3 plus a x raised to the power 2 plus ax minus b. That's f of x. So we have to now substitute those values in this, and now that will be equal to 2x raised to the power 3 plus 14x raised to the power 2 plus 14x minus 30, where a is 14 and the b is what? 30 minus 30, and so the b is 30, sorry. So we now have f of x as 2x raised to the power 3 plus 14x raised to the power 2 plus 14x minus 30. So remember they said factorize f of x completely. Remember why the word completely? Therefore it shows that there was an initial factorized equation. In other words, this simply telling us that f of x was factorized, but it was partially, which is why they gave us x squared plus 2x minus 3 as the factor, meaning that when they partially factorized f of x, the factor was x squared plus 2x minus 3. Now we are asked to find the remaining factor. Now how do we do that? Now first, for us to factorize completely, now this is the main equation that we have. So if I look at this expression, you notice that 2 is common to all of this. I may decide to factorize 2 out, and that will become 2 into x raised to the power 3 plus 7x raised to the power 2 plus 7x minus 30. If you factorize 2 out, in other words, 2 is common to each of the terms, so I decide to place 2 outside while we have this inside the bracket. Now we have to now consider this to be our main expression, which of course if I'm to use the long division method of polynomial, this will be my dividend. Now I will do this quickly. Here will be what? The x cubed plus 7x raised to the power 2 plus 7x minus 30, while x squared will be here plus 2x minus 3. Now I want to apply the long division method of dividing a polynomial. Remember that if I use this to divide this, the remainder must be 0. From the beginning we were told that x squared plus 2x minus 3, if it divides this expression, the remainder will be 0. Now how do I go about the division? Remember we have 2 already here. This 2 will come into play. 2 is common to all. I factorize the 2 out for simplicity because I know that 2 is common to all the terms. So it's better I remove 2 as I factorize the 2 out, so that it will be easier for us to handle these figures or these numbers. Now if you look at this, you discover that the highest power of this is 3, because the first term has power 3, the second term has power 2, this one has power 1, this has power 0. Therefore means the highest power is power 3. The highest power here is power 2. So what that means, what that's telling us is that we will have to be using this x squared to divide this one. So I will say x squared into x cubed. Simply say x raised to the power 3 divided by what? X raised to the power 2. When you do that, the answer will be what? X. That x, I will place the x up here. I will now say x times x squared. Remember, please, I've told you I've done a video on division of polynomial. So you can look for that video. You have understanding of how polynomial can be divided. Now x times this will give us what? X cubed. X will times this will give us plus what? Of course, if x times this will give us 2x squared. That will be 2x squared. If x times this, that will give us minus 3 1 x. Once you have used the x to multiply, you draw that line and then introduce your minus sign. You have to introduce a minus sign because we want to eliminate, we want to make sure that the x cube turn to 0. If you introduce a plus sign, the x cube will not turn to 0. Now I will now say x cube minus x cube, that will be what? 0. 7x squared minus 2x squared, that of course will be what? 5x squared. I will now say 7x minus 3x, that of course will give me what? 10x. That will be plus 10x. I'll bring down the minus 30. At this point, the power here is 2. Highest power here is 2. While the power here is still 2. The highest power here is 2. So I have to continue to divide. I will now say x squared into this. That's into this one. That's to say 5x raised to the power 2 all over what? X raised to the power 2. And this, of course, will cancel this one. You'll be left with 5. That 5 will be written here plus 5. I will now say plus 5 times this, that will give us plus 5x raised to the power 2. 5 times this will give us plus 10x. 5 times this will give us minus 15. That will be minus 15. Please here, there was a mistake here. Remember, if we factorizing 2 out, please, here would have been what? 15. Here will be 15. Please take note. Here will be 15. Please. So here has to be 15. All through here is 15. Please, 15. That will be 15. So if I have 5 times this will be minus 15. And so I would do this. I introduce a minus sign again. If you introduce a minus sign, 5x squared minus 5x squared, that will be 0. 10x minus 10x, that will be 0. Minus 15 minus 15, that will be 0. So everything here will be 0, 0. You can now see that at this point, your remainder, it has further confirmed that when you use this to divide this polynomial, the remainder will be what? 0. So we now have, this one we now have finally, because they say factorize completely. Factorize completely. Now we have this as our factors. Please, our factorize. Look at, we have up here x plus 5. We have x plus 5 as one of the factors. Earlier we got 2 other factors when we factorize x squared plus 2x minus 3. We have 2 factors. Remember, when we did that, we got x minus 3, and we got what? X minus 1. Okay, x plus 3 and x minus 1. These were the values that we got. So we will now bring them here. That will be what? X plus 3 and x minus 1. So remember that these two, we got these two when we factorize this, since this can factor, this is also a factor of this. So while x plus 5, we've gotten it from here. And now remember earlier there was 2 outside here. We factorized 2 out. So we're going to have what? 2 here. That means all of them, there will be 2 here. So it means that factorize f of s completely. This is now the answer. We have factorized completely. The answer becomes this. Now the second question is state the zeros of f of x. State the zeros of f of x. For you to state the zeros of f of x, from these factors you can get it. From these factors you can get it. Now the zeros means that x plus 3 is equal to 0. Therefore x is equal to minus 3. This is one of the 0. X minus 1 is equal to 0. Then x is equal to 1. This is another one. X plus 5 is equal to 0. X is equal to minus 5. This is another one. So the zeros, please take note. This is the second question. The zeros is simply by equating the factor to 0. And once you do that, you're going to have what? X minus 3, x equal to 1, x equal to minus 5. These are the zeros of that expression. And finally, we were asked to find the remainder when f of x is divided by x minus 5. Find the remainder when x is divided by what? We're asked to find the remainder when f of x is divided by what? X minus 5. To answer that, remember x minus 5. That's the x minus 5. They said we should find the remainder when x minus 5 divides this. How do you go about it? Simply say x minus 5 is equal to 0. Therefore, x is equal to 5. You now look for what? The remainder, which is f equal to f of what? 5. What that means is wherever you have what? X, you replace with what? 5. And of course, that will give you That will give you remainder equal to 2 into 5 raised to power 3 plus 14 into 5 raised to power 2 plus 14 into what? 5 minus 30. Now you solve this, whatever you have becomes what? Your final answer. So after substituting x equal to 5, this is what you now have. If you solve this with your calculator, you expect to have about 640 to be your answer. So at this point, I want to believe you have understanding of this. In case you have any comment, in case you have any question, please drop it at the comment section. Again, like this video, share it if you find value. Thank you.